Have you ever found yourself wrestling with a new AI application? Trying to make it do something really specific. And it just feels, well, it feels like you're trying to drive a monster truck through a crowded mall with these tiny little joysticks. All that power, but just zero precision.
It's a surprisingly common frustration, actually, isn't it? Because,
Hmm.
despite all the incredible advancements, many AI systems haven't quite had their chat GPT moment, where everything just clicks and feels intuitively right.
Hmm.
And a core reason for that persistent disconnect is that AI agents often miss the right context, especially in the world of enterprise, right, where workflows are complex, highly specialized.
Absolutely.
This lack of critical specific knowledge, it can feel like the AI is trying to help, but it just doesn't understand the nuanced rules of your particular game.
Exactly. It doesn't get the specifics. So today we're taking a deep dive into a really powerful solution, agentic workflows. These are stepping up to bring much needed control, reliability, and yeah, precision steering to these highly autonomous AI systems. We're going to unpack some truly crucial insights directly from an expert at FactSet, a major financial data and software company. They've been right on the front lines building these systems.
Yeah, and what's truly fascinating here, I think, is how these concepts, while they are rooted in an enterprise context,
Hmm.
they really offer powerful blueprints for anyone, really. Anyone looking to gain control and predictability over AI agents, all while keeping that vital flexibility. We're essentially going to show you how to, well, tame that monster truck and give it a GPS.
Okay, love that analogy. So let's unpack this. The world of AI is, let's be honest, notorious for its confusing
Well,
terminology.
no, absolutely.
So before we jump into the how, let's get our foundational definitions straight, drawing from the experts' insights. First up, an augmented LLM. Now, this isn't just your standard large language model. Think of it more like an LLM that's gone to finishing school. It's enhanced with additional tools it can use and memory it can access, so it's smarter, more capable.
Right. It has resources.
Then we have a workflow. Imagine this as an augmented LLM operating on a static, predefined path. It's like a meticulously planned recipe. Every single step is known in advance, which makes it incredibly controllable and reliable. It does precisely what you tell it every single time.
Very predictable.
Exactly. Now, here's where it really diverges. An agent. This is also an augmented LLM, but crucially, it's equipped with high autonomy and a feedback loop. So unlike the rigid workflow, an agent can adapt. It can learn, it can make decisions on its own. It's not just following a recipe. It's like it can invent new dishes.
That's a good way to put it. It has
Yeah.
agency.
Right. But here's the curveball, the one that trips up even, seasoned AI pros sometimes. The difference between a workflow agent and an agentic workflow.
Ugh,
They sound almost interchangeable, don't they?
they really do.
But understanding the subtle shift in control isn't just semantics. I mean, it fundamentally changes how AI behaves and how powerful it can become.
Yeah, if we connect this to the bigger picture, the key, really, is understanding who's truly in the driver's seat. In a workflow agent, the workflow itself is static. It dictates the process, and it's run by an agent. So the agent is essentially like a highly skilled worker diligently following a pre-written script.
Okay.
But in an agentic workflow, the agent is always in control, and the workflow is dynamic precisely because it's actively planned and run by the agent. It's the difference between executing pre-written instructions versus having the intelligence to create and adapt the instructions on the fly.
Ah, okay.
And when we talk about an agentic spectrum, agentic workflows definitely sit much further down the more agenticness end, more autonomy.
That's a fantastic point about control. So, okay, why is this distinction and this whole concept of agentic workflows, why is it so crucial for you, our listener? What's the payoff?
Well, agentic workflows truly offer the best of both worlds, as they say. They combine that robust control and reliability of traditional workflows.
Which enterprises love.
Exactly. But they combine it with the flexibility and the adaptive autonomy of agents. And this is a huge leap forward because it tackles a very real enterprise headache. That inability to fully automate complex, nuanced processes. Imagine a financial analyst, right, who used to spend hours dishing together data from maybe 5 different systems for one critical report.
Yep, classic scenario.
Traditional automation might get you, say, 80% there,
Yeah.
but that last 20%, the nuanced, context-dependent decisions, that always required human intervention.
Always.
Agentic workflows, though, they don't just automate that 80%. They can intelligently navigate the exceptions, the dynamic data points, delivering a truly complete, high-quality report without a human needing to handhold it every step of the way.
No.
That's the real game changer.
Wow, okay.
For companies, it means they can automate workflows at an unprecedented scale. And critically, they can build directly on top of their existing enterprise microservices.
Ah, that's huge.
It's vital
Yeah.
because companies have often invested, years, if not decades, into these systems. So this approach is a way to preserve that immense investment while unlocking entirely new levels of capability.
So for you listening, this really means leveraging all your existing strengths, all those systems, those processes you've already built, while unlocking these new levels of automation and intelligence. And it's applicable not just to huge organizations, right? But potentially to your own work, your own projects,
Mm.
allowing your existing systems and knowledge to become even smarter, more dynamic.
Right.
Okay, this brings us to a fascinating shift in mindset then. Because for a long time, the focus in AI building has often been on, well, React-based agents, right? Agents that just respond to immediate inputs. But for these powerful agentic workflows, we need to move towards proactive agents. In fact, our expert source called this shift a great philosophy for life, moving from reacting to anticipating.
I like that. It's about thinking ahead.
Exactly. And when you're building these proactive agentic workflows, you need three core components. You need robust tools for the agent to actually use, sufficient memory to retain information across steps, and the ability for reflection, meaning the agent can look back at its actions and, well, learn from them.
Right, those are the foundations. And beyond those, the key design pattern for these proactive agents is what we call planning by sub-goal division. It's often referred to as task decomposition.
Okay.
And it's actually quite simple in concept. You
Yeah.
take a complex, overarching goal, and you break it down into smaller, simpler, more manageable steps.
Makes sense?
But this raises an important question. How do you actually implement this breaking down of tasks in a robust way? So that AI doesn't get overwhelmed or go off on a tangent.
Yeah, how do you structure that? And this is where it gets really interesting because FactSet has tackled this head on. Let's look at how they adapted what's known as the LLM compiler architecture to solve this in practice. Now, for listeners who might not be deep into AI engineering, just think of an LLM compiler as a kind of sophisticated orchestrator. It takes an LLM's raw intelligence and structures it to perform complex tasks.
Right, it provides the framework.
Exactly. And FactSet defined four core components, or nodes, in their specific architecture: the blueprint generator, the planner, the executor, and the joiner. And for those familiar with development tools, these are implemented as nodes in LangGraph, which is a framework that helps manage these complex chains of AI actions.
Yeah, and we really need to zoom in on that blueprint generator because it's described as one of the key architecture changes FactSet made, and frankly, it's quite brilliant. Its primary role is generating a high-level plan. They actually call it the blueprint.
The blueprint, okay.
And this blueprint is basically a series of workflow steps, but described in plain, natural language. It's based on the capabilities of the available tools, and then it feeds directly into the planner component.
Natural language, that's interesting.
It is. And the benefits of this blueprint approach are, well, numerous and profound. First, it significantly reduces the cognitive load on the planner. Without it, the planner could get very much overloaded trying to figure everything out from scratch.
Right.
Second, it helps limit the in-context tools provided to the planner. This effectively addresses those perennial context window limits that can really hobble larger LLMs.
Oh, okay. That's clever.
It also gives you final control over task planning, which is huge for enterprise reliability. And it greatly aids in interpreting agentic behavior when you need to debug something. But here's the kicker, I think. Because it's in natural language, it's less intimidating. It's really helpful for collaboration with non-technical people. You can literally show a business user the AI's high-level plan.
Wow, that natural language blueprint does sound incredibly powerful for collaboration, getting everyone on the same page. But I can imagine, as developers, we might initially resist giving up that direct code level control over every little step. Was that a common hurdle? And how do you convince teams that this high level plan actually gives more control in a way, not less?
That's a great question. And yes, it's definitely a common initial reaction. It feels like losing control. But the shift is really from micromanaging the AI's every single thought to architecting its higher level strategy. The blueprint defines the guardrails, it defines the overall objective, but in human readable terms. It ensures the AI stays within the intended business logic.
Okay, I see.
It's kind of like a seasoned architect handing a detailed blueprint to a skilled contractor. You trust the contractor to execute the low-level details, how to pour the concrete, how to frame the walls. But you, the architect, retain ultimate control over the vision and the structure.
That's a great analogy.
And this actually allows us to scale much faster and ensure consistency across diverse applications, precisely because we're not bogged down in the tiny details of every single interaction.
That makes perfect sense. So the overall flow becomes blueprint generator creates that human-readable, high-level plan. The planner then handles the low-level tasks, figuring out the specifics based on that blueprint. The executor goes and actually does those tasks, uses the tools, and the joiner, it combines the outputs from different tasks and manages the replanning logic, including, importantly, setting recursion limits to prevent the agent from getting stuck in endless loops.
Exactly. That loop prevention is crucial.
It's a remarkably robust structure when you lay it out like that.
It is.
Now, our expert source emphasizes that for most developers listening, building the tools that these agents use, particularly building them around existing enterprise microservices, that's likely where they'll spend most of their time.
That's spot on. And the most key point for tool design, the thing you absolutely must remember, is that you have to put yourself into the agent's shoes.
Okay.
You need to ensure the agent truly understands how and when to use your tools. Think of it this way. You're not just doing a simple mapping, like one tool equals one microservice call. No, you're sculpting how those microservices present themselves to the agent, making sure the agent understands their capabilities like a human understands their own toolbox.
So it's about the agent's perspective.
Completely. The relationship between tools and microservices is definitely not one-to-one or end-to-end. It's all about how you design them to be agent-friendly. And for each tool, you need to provide crucial details to the agent. The tool purpose, this helps the agent decide what tool to select from its arsenal for a given task. The tool description, this guides the agent on when the tool needs to be invoked, gives it that vital context. And the input-output contracts these instruct the agent on how to use the tool, detailing exactly what data it expects and what data it will return.
Purpose, description, contracts. Got it. And beyond that, they also recommend following standards, right? Like building an MCP tool server.
Yes, MCP, think of it as a standardized way to package and expose these tools across an organization, like creating a shared corporate toolbox that any agent can potentially access.
Makes sense for scale.
And critically, you need to include validation checks. These act as vital safety guardrails for the agent. They prevent it from going off the rails, misinterpreting instructions, or using a tool incorrectly.
Safety guardrails absolutely essential.
Mm-hmm.
Okay, let's bring these powerful architectural concepts to life. Can we walk through a concrete example, maybe from financial research, like preparing for a company's earnings call? We could use, say, NVIDIA as a simplified illustration of the kind of complex multi-step workflow we're talking about.
Sure, that's a great example.
So a typical blueprint for something like that, generated by the blueprint generator, it would likely involve several steps, all planned and executed by the agent. First, maybe summarizing a previous earnings call to grasp the historical context.
Right, need that baseline.
Next, retrieving relevant financial data, recent filings, analyst estimates, market data probably from various internal and external sources, using specific tools.
Mm-hmm.
Then maybe the agent needs to reason about that data, compare performance, identify trends, and perhaps suggest insightful questions for the upcoming call based on its analysis.
Yeah, the value add part.
Exactly. And finally, generating a comprehensive report from all that gathered information, perfectly tailored for, say, a busy financial analyst.
And what's truly fascinating here, and what really sells the concept, is the tangible difference in the final output. Before implementing this kind of agentic workflow, the response you'd get might be, well, pretty much vanilla, as the expert put it, a generic summary, maybe some data points.
Right, basic.
But afterward, because the agent can easily capture your specific nuanced workflow and execute it reliably, you get a very structured response that directly addresses the analyst's specific needs in the format they prefer with the insights they require. This clearly shows the practical value proposition to you, the listener. It's not just about automating rote tasks anymore. It's about delivering higher quality, truly tailored, and deeply contextualized outputs at scale.
That difference is huge. Okay, now something you mentioned earlier and the expert stressed heavily is evaluations or evals. For many engineering teams, let's be honest, evals can sometimes feel like an afterthought, right? A nice to have when deadlines are looming.
Unfortunately, yes.
But you're advocating for them. And the expert source insists they must be treated as a first-class citizen, almost as important as the code itself. Can you elaborate on why that shift in mindset is so absolutely crucial, especially for these agentic systems where behavior can be quite fluid?
You hit on a critical point there. For agentic systems, precisely because the AI makes decisions and its behavior can be fluid, evils are not optional. They are the absolute bedrock of reliability and trust. You absolutely need to invest and build and maintain your evil framework. The recommendation is at least component and end-to-end evils.
Hmm.
Without proper evils, you are quite literally flying
String
blind.
blind, yeah.
You won't know if your agent is truly performing as expected. You won't know if it's drifting over time, or if a subtle change you made somewhere else has introduced an unexpected error downstream. For specific evaluation techniques, you should consider a mix. Code-based evaluations are great for deterministic checks. Did it use the right tool? Did it extract the right number? Using an LLM as judge is powerful for more subjective quality assessments. Is this summary coherent? Is the reasoning sound? And incorporating a human in the loop is essential, where nuanced judgment is paramount, or for setting that initial quality bar.
Okay, a mix of approaches.
Exactly. And to give you some concrete examples of these aspect-based evils and the best techniques for each, drawing directly from the FactSet experience. Checking if a generated blueprint resembles a golden blueprint, meaning does the AI's high-level plan align with a human-defined ideal plan? That's best done using an LLM as judge. Verifying if tools are selected correct. That lends itself perfectly to code-based evils. It's a direct functional check. Yes or no? Assessing if the lower-level plan is in line with the blueprint, again, an LLM as judge, can work well there for semantic alignment. And finally, evaluating something like report formatting where aesthetics and user experience are key. Well, that's where human in the loop is definitively the best approach. An LLM might not care about perfect table alignment, but your users certainly will.
That makes total sense. And this really raises an important question for anyone building with AI, doesn't it? Are you evaluating what truly matters to you in your specific use case, or are you just evaluating what's easiest to measure?
That's the million-dollar question.
Because that distinction can make all the difference between a system that works in theory and one that actually delivers value. Okay, we've talked a lot about the power and the promise of agentic workflows. But for balance, it's really important to touch on scenarios where they, well, definitely don't make sense, as the expert put it. Where should they probably be avoided? They're powerful, but they're certainly not a silver bullet for every single problem out there.
Absolutely not. And it's crucial to know when not to use them. Other approaches are likely better in several key situations. First, for fixed and repetitive tasks. If the process never changes, it's the same thing every time. You're likely much better off with traditional ETL pipelines or just simple scripts. You don't need the overhead and complexity of an agentic workflow. You don't need a Ferrari, as you said, for a trip to the grocery store.
Right. Keep it simple.
Second, if the use case cannot be really captured in workflows, if it's just too unstructured, too nebulous, too creative perhaps, agentic workflows might struggle or just not be worth the effort to define. Third, and this is a big one, when a deterministic outcome is paramount. Think about strict compliance in safety-critical contexts, like medical diagnosis recommendations or generating legally binding advice.
High stakes.
Very high stakes. The inherent autonomy and potential variability of agentic systems might introduce too much risk there. You need something completely predictable. And lastly, in low latency and cost environments, where every millisecond and every fraction of a cent counts. The overhead of agentic reasoning, the planning, the reflection might just make them unsuitable from a performance or cost perspective.
That's a really crucial set of caveats. It helps you, the listener, avoid trying to fit a square peg into a round hole, right? And ensures you're applying this powerful concept where it truly provides the most value, not just because it's the latest shiny object in AI.
Exactly. Choose the right tool for the job.
So we've covered a huge amount of ground today. From the conceptual backbone, the definitions, all the way down to the nitty-gritty of building these systems, the tools, the evils. As you sit with all this information, what should be the absolute sort of non-negotiable takeaways you carry forward from this deep dive? What are the core learnings?
Okay, let's try and distill the core learnings and key takeaways from the expert insights. First, always start with simple blueprints. Don't try to boil the ocean, gradually build complexity.
Start simple. Good advice.
Use those blueprints strategically to reduce in-context tools for the planner and give that clear, high-level plan. Less cognitive load. Crucially, remember to design tools from the agent's point of view. Always aim for simplicity in how the agent perceives and uses your tools. Think like the agent. Implement safety guardrails, rigorous evils, robust observability, and just generally good software engineering practices. This isn't magic, it's engineering. Reiterate this mantra in your head. Agentic workflow is planned and run by agent. That's the core difference.
Planned and run by the agent.
And this is what brings reliability at scale. Remember also, planning by sub-goal division is a key design pattern. Break things down. And plan and execute is a key agentic architecture. Think about that cycle. Build your tools to complement your microservices and absolutely leverage your microservices whenever possible. Don't reinvent the wheel. Preserve that existing investment.
Leverage existing strengths.
Yes. And don't be afraid to modify your architecture based on what you learn. Don't be afraid to experiment with ideas from research papers to solve your specific problems. Innovation is key here. And finally, crucially, I'll say it again, treat your evils like a first-class citizen. They are not optional.
Treat evils like a first-class citizen. Got it. That's a fantastic summary. And maybe just a quick final note on those orchestration tools we touched upon, like MCP and LangGraph. Just to clarify the expert's perspective, MCP seems to provide that robust standardization for tools across an organization, that build once, use everywhere philosophy you mentioned.
Right, the shared toolbox idea.
While LangGraph is seen as great for orchestration of the agent's actual decision-making flow, managing the state and transitions between those blueprint steps.
Yeah, they serve slightly different but complementary purposes.
And ultimately, as you noted from the source, it's often multiple things that are useful, right?
Okay.
Depending on the specific use case and what's most optimal for your unique framework, you might use both or others.
Exactly. It's about picking the right combination for your needs.
Okay. So as we wrap up this deep dive, it feels really clear that agentic workflows offer a genuinely transformative pathway. They can help us move AI from that initial frustrating monster truck with tiny joysticks feeling towards a system that's much more controlled, much more reliable, yet still dynamically flexible. One that truly understands and adapts to the context of your goals. Essentially, putting you firmly back in control, but with a much smarter co-pilot.
Well put. And maybe this raises an important final question for you, the listener, to ponder. How might reevaluating your own information flows, whether that's in your personal learning, your professional tasks, or even just how you approach complex problems day to day? How might looking at them through this lens of agenticness, of proactive planning and execution, how might that uncover new opportunities for greater control, more dynamic processes, and ultimately more intelligent outcomes?
That's a great thought to leave people with. And on that note, maybe we can encourage you to explore that core concept of planning by sub-goal division in your own daily problem solving, even completely outside of AI applications. Because as our expert source noted, it truly is. Well, it's a great philosophy for life. Break it down, plan it out, execute.
Couldn't agree more.